Alright, mic check, YouTube. And now mic checking on Twitch. The music on. Greetings, civilized people. Today I'm gonna be doing something meaningful on the content creation for the first time ever. We'll be doing some design project. Alright. And now let me put back up the music on Twitch. Which is this one. You are listening to the Ocean 11 soundtrack. Right from the movie itself. Alright, I think we're good to go. So, I hope you like my new settings. It's actually the same settings as the last time, but it's from my previous computer. It's different because I push away the webcam by a lot further. Now it used to be like up in my fucking, sorry. Now it used to be in my face. All right. Now it get back further away from my face. Now what were they doing? Get back to the main scene. All right. Well, actually, we don't need any of the notepad. Let's just do this with this. Okay. My name is Lyman. Lyman Circa. I've watched this movie like 1,000 times. Not 1,000, but a couple of hundreds. I can tell you that. What was I doing? Okay. So today we'll be doing some. No, this is not the tool I'm using. This will be. Can I? Okay, thanks. Let's move this down a bit. Yep, there we are. We'll be doing some design. It will be slightly diagonal. Design. Pardon my handwriting. It was supposed to be better than this, but as you can see, the Wacom is way off to the left side. Okay, let me just adjust a bit. I'm gonna use more of the Wacom, then that even a good idea. Yeah, I can use both mouse and Wacom on the Wacom. You know what I'm talking about. Oh shoot. All right. Okay. Now we're doing some design project, which, pardon me for a second, my mouse wire is short. You know what? I hate this. I hate this handwriting. Let's just scratch these. I used to like listen to this recording, I mean music that you are hearing on Twitch right now when I was doing my thesis. Believe it or not. Okay, this is not this is kind of not good. Let me just something a bit. Pardon me for a second. This. Oh my god. Why? I'm having too many things on my desktop. Now, this should be a lot better. Alright, this would work. Holy cow. Can't imagine how much time I spend on setting this up, and then I have to resetting again. What the? Every time, bro. Telling you. Okay. We are ready, I think. That's what, about 10-minute mark. Note. 10-minute mark. Yep, better handwriting now. I am ready. This is just for the timestamp. For editing later. Oh my god. It doesn't wanna follow my head. Design project. Right, so as you can see behind me right here, is the big cupboard. Okay, you see it's like shadowy or It's not shadowy. It's covered in dust. I've been rod maxing for about 7 years. Yes. Not actually 7 years. I've been working here for about 7 to 8 years. But I've been rod maxing since 2020 when COVID happens. Whatever. That's story for the other day. So we're doing this design project. What I want to do on this one is to make it not covered in dust like this. There's an inch thick of dust covered everything right now behind me. So we're doing the acrylic frame design. The zing. Remember, kids, don't ever type sorry, crap, don't ever type this in your presentation. Please don't do it. Sorry. Oh my god, I got whatever that was. Don't do it. I can't count how many times I've seen people studying design and in their presentation you have this. Don't do it, please. Okay, we're doing acrylic frame design today for that cupboard behind me. Which, wait, what frame? Oh, okay. I gotta switch back to this, right? Yes, I am. Okay. So the framework, on the framework, we'll be using SolidWorks as a software. But I'll be showing you the process from start to finish. Like from the start of having the idea of doing the project itself up until the point where I have the freaking thing and I will be assembling it on here in about a week because I only have that much of time. I'll be streaming, I think I'll be streaming every day for the next week and a half. So the process from start to finish, I shall list it up front. So the start process, the design process usually starts with the briefing. Well, with design project, let me elaborate on that for a bit. Briefing, you can see, you can look at whatever. I have to erase this. Okay. Delete all the junk, please. Let's not segue out into garbage here. All right. Now, what I can tell you up front is the word project, as we are approaching it like an industrial designer would do, or a product designer would do. A project or a design project, right, is kind of equivalent to a problem, right? So what I mean by that is throughout your life with this lesson, throughout your life, whatever the problem you are facing, you can use this approach on any problem. Doesn't matter if it's design or engineering or painting, whatever, right? So every project will start with the briefing, and then we'll have what we call preliminary sketch. You might, from someone who came from the industry themselves, might familiar with the term sketch design. Okay, so all of these kind of is the lingo of design, of product design. I should say product design. Okay. In other shortened term, you might be seeing it as SKD, is calling sketch design for short, right? So after the prelim, you might have multiple alternatives, like we could call it iterations, right? Basically, like whatever you come up with in the second process. The first being briefing, second being prelim. So whatever you come up in the prelims process, you will have to develop them further. So when we study the design, we call it development. Right? It's when an idea trying to transfer or transform into what is buildable or producible in real life. Okay, after the development, then you will have well, basically just choose out whatever you come up with and develop in the third process. Basically, I can't remember the term, actually, pardon my the term was in the book back there. If you can see that one, the yellow cover book. The name of the book is the Industrial Design Process. Every process in there just listed in that book, but I haven't read them for a good old long time. So we can call it finalize. Yeah, after the development, it's actually time, if you are working for some client or something like that, it's when you wanna finalize the project so that you get paid. Right? Usually we got paid upfront in advance for the down payment, but then the rest of it will be paid after you finish the project, unfortunately. So you will finalize in the finalized project, I mean in the finalized process, it will involve manufacturing, well, actually we call it working drawings, but in the general terms, let's not do that R. Okay, this is R. Manufacturing drawing or working drawings. So the working drawings would be used to set out to the manufacturer to produce the stuff, right? Working drawing can be called in short in DWG. What else? If you're in college, the next step after you have the working drawing would be having the presentation. right? So throughout this process, we will document everything that we come up with within this design project, so that we can document, I mean, we can have the presentation at the end when we have the final product. So we have like the whole process from starting the idea briefing and then getting the final product in place. That's about it. Okay. Let's see how much we have left on the paper. Quite a bit. In that case, then we're gonna start the brief down here then. Let's up it a bit. How's it now? 4? Yeah, 4 is fine. I want to do 7. So this would be the brief. Well, we should call it. You can use this template to do the design commission as well. Design brief. This is when you will ask your customer, if you doing the commission, about how the design project would go, right? Starting with let's go back to 4. Okay. The brief usually we should start with the subject. Our subject here is the big board. We'll call it big board then. Subject big board, acrylic. Yeah, we can define the final material as its subject, because we know at the end the product's gonna be produced by laser cutting machine or the CNC cutting. It doesn't matter. Water jet, what doesn't matter. It will be cut out using the machine, using our working drawings, and then put together by me, and then put there, and then there will be no dust in the cupboard anymore. Acrylic frame design. How about that? I should start with. Okay, yeah, I actually should start with finishing this brief first and foremost. And next, from subject, we will list the requirements. Okay. Requirements is something that would define the product purpose, like generally, and it can be listed in multiple points, which is first to keep out the dust is the main requirement for it. Keep out dust. Next requirement, I would say, to be sturdy enough. Sturdy and firm when we using its function. So when we have to be able to open and close. Wait, this should be this can be a third requirement. Actually, the second requirement should be open and close. Wait, what the? Oh, wait, what the hell? What the hell's going on here? Open and Oh, now I know. Something's hitting the mouse. Oh my god. Open and yeah. I should say shut. Open and shut. Alright. These should be the only requirements. Minimal drill. We don't want to like Frankenstein our cupboard here and like put it to the bad state of structure, you know. It should be minimal drill holes. Drill holes. Why is it every time I'm using my brain, my stomach's starting to get hungry? Every time. Why? That should be it, I think. Clear and yeah, firm and clear. So that's why it should be acrylic. Next from the requirements, we would have criteria. Criteria is the condition that we will define whether our design is good or not when we are going into the development, right? So when like let's say when you have 3 alternatives, how do you choose the best one? You will use the criteria. Okay. The criteria should be like using acrylic structure by itself. Well, this is kind of, yeah, this one is kind of more like a criteria than requirements. This one. This one should be criteria. So that's number 1. Number 2 is sturdy and firm, because we will have to like move them multiple times throughout when we are putting out things in, you know. And well, actually minimal drill hole should also be one of the criteria. So we have 2 requirements. Basically, we don't have to make it too complex, and with the 3 criteria to make up the design for it. Okay. Now, if I will share my display screen, does it come up? Does not. Up until I put this down then. Okay, now you see all on my screen. So now after we have the briefing done, what we should do first is, whatever you do, whenever you start the project, you just have to make up the new folder for it. That's the best practice I can give. New folder, and just call it acrylic frame. Wait. For best practice, you should even put in your year 24. Today is October the 15th. That's how I put it. I used to put the number before, but it looks kind of annoying because like the good thing about putting a number before is it will always sort out. When you sort by name, it will always sort out by time. Like, you see what I mean? But yeah, in this case, we don't need that. So now we have our working folder. Now, whatever we write on here, we'll just save it there as a sketch. Okay. Which is where the video content. There we go. So now just name it skd 0. Name it. You don't need to have dash. Brief. Wait. Intro and brief. .png. Okay, sure. I'll save it. Now we can erase everything here. We just use layer. Well, actually, we can just add a new layer, right? We hide this one. We work on the next one. Then this way we have the same. The same file containing every page as we sketch on. Okay. Now will come the preliminary sketch. This is the fun part. The very, very fun part. Let's just change to calligraph. Yeah, I want to use calligraph because I can't use it in real life because I'm left-handed. That sucks. So now, the second step would be preliminary sketches. Okay. Which one? Pencil? We just start by drawing the cupboard itself, the subject itself. The cupboard just look like this. This is gonna be a rough sketch. Actually, guys, don't expect any beautiful thing come out of it because it's on Wacom, remember. Now, this line wouldn't work. There. It goes this way, this goes this way, it goes up. And it has 4 floors in total. It means it goes. Wait, I should use a black for rough sketch. Half of it. Here goes here. Yeah, never mind. Here, and then yeah, it's about this wide, I think. Yeah, go this wide. Right, and then come down here, you have thickness. Wow, bad drawings, but oh my god, sorry. Yep. No, actually no. We could do a line actually, if like there, but I don't wanna. I'm very bad at drawing on the Wacom, as you can see now. My god. I'm nervous now on the sketch design. Whatever. We could just like do it for for an idea, you know. Don't have to go hard on myself that much. I'm very bad at sketching anyways. So this is the first floor, this is the second. The third should come here. Around here, third. Alright, and the fourth one, the top one is the open on top. So it looks like this. And then we have the back side in between the two plates. Okay, bad sketch, very bad sketch, but regardless. And then you have two splitters, which is one is here. We doesn't go all the way in, like come out halfway. All right, about there, yes. Okay, now there. Now we have our board. So my idea was initially my idea was to be able to put the frame in each level that it has. Dude, my drawing sucks. This should not be even here. Okay, it should be here. Down. Also this one. There. Okay. So the idea, if you look at the front view of it, like, right, let's imagine that I draw a straight line here. You know what? You know what? I'm a cat drawer anyways. I'm a 3D modeler, right? So the idea, right? If you want to look at it from the front view, pardon. Okay, this is front view. If I may, you will see that the cupboard looks like this, with the side plate be on the side. It should look like this, and then this side, right? And with each, this is the first, the footing, like the base of the cupboard. Okay. The second floor will be around here. Then comes the third. And the fourth one here. Okay. And the one that's on vertical here would be around this. Oh, come on. Not the same size, but wait, I think I can copy it, right? Can I? If I press Control or Alt? No, it does not do that. That's just not Adobe Illustrator. Okay, never mind. So we'll just do this. Should be the same size here. Okay, whatever here. Move a bit. Okay, there. The idea, let's do it in red. Wait. Well, no. Oh my god, I messed it up. I messed it up. Wait. Now. Oh my god, it takes forever for me to put this as it is. Now. The idea is to create something that fits into here. Okay. Yeah, it can be over on the top or whatever. And the next one will fit into the next space in here. Okay. So basically we have the closure for the cupboard, but with the function that it can be open and closed, not just like you can have one plate of acrylic and just drill it into the front and be done with it, but that's not how I do it, right? So we can have like some variants of how we are gonna open and shut the window as well. Let's see. My first initial idea would be on the top row, right? We can't have like, we should be avoiding, oh wait, if I'm gonna sketch, please, we should be avoid having the acrylic bended like this shape. This is a definitely no-no, right? Like this. And then you can open it up like this way. It looks good, but it's a no-no because this one is really hard to make, the bend. It can mess up your whole project if you're not careful. So we will avoid doing this at all costs. That means our design should be like in the box shape only on top. So we can have it like if the cupboard would look like this, and it has its radius down here. Okay. But we can have the square shape cover, but it would cover around the outside, you know, around the outside of the whole thing. And also this corner here would have to be done in like the hinge manner, in the hinge fashion. I mean, it has to be hinged because the other thing we wanted to avoid is same color. This is also what we want to avoid when designing acrylic material. We would want to avoid having the corner of two plates glued together like this. You know, you put together and use the glue in the middle, right? You can glue up acrylic and it can have it still be clear, but the problem with this also is the weakness of it. Basically, it will be prone to break if you do it like that and you don't have any structure to support it. So by structure, you can have the hinge to support, Well, actually the hinge can be glued on, right? You don't have to drill. You can drill. You could use the screw to drill down onto the piece, but I don't think it looks good, so we're gonna have the glue-on type hinge on this part. Okay. And since we will also have to avoid one more thing, which is like the long plate of acrylic, the longer the length it is, it will prone to bend. So like a big clear flat plane is also a no-no. Okay, that means we will have to split these like in parts, maybe at least 3 parts. Let's rework this for a bit. That one's okay. This one should be around here. The hinge, let's say the hinge is here. The glued on type. Now we can split them into 3 parts. Just for the strength of the structure, right? This will also have to have its own hinge. Or actually not. I was thinking about the module kind of design. Actually, let's move this too. It looks kind of dumb. This one will be moved down here. Okay, as example, we still draw the screw so that like at the end it doesn't have to be this, but if you have the customer or you're working on a commission project, it's good to express your multiple ideas into one sketch design, so that way you don't have to draw multiple times basically. Okay, so what I was thinking is this middle part. So since we have the structure on the side of it, this is a structure by itself, because this is wooden. All right, the base cupboard would be wooden, so that it has its own structure to hold on the side, on both of the sides. That means 2 of these parts have the support structure for it, except the middle one would be the most weakened spot of the whole thing. That means that we have to design some structure for it to be able to hold. Are we out of? Oh my god, we are out of paper, but never mind. We have a new page to use. Okay. So the schematic, I mean the idea for the side, it can be done by how are we gonna do this? The top plate can have the side that cover outside of the cupboard, meaning it has to be glued in this fashion, I think. Okay, but it might not have to be too long for its length down here. This one, can be like what, 10. Yeah, our unit would be millimeter. Sorry, American Standard, we're not using you. We're using the international standards. Isometric. Oh, wait, what's it called? The ISO standard. The metric standard. Okay, so that's 10 mil on each side. So it might have to be supporting flap on this side as well, going in to the middle. But the idea is to have, wait, if this is a cupboard, the cover will come out of it a bit. The cover down on the side. Oh my god, my drawing is bad. So that way it covers all the dust and not let it in. If we put it inside, there would be no way to... Oh, it can be. Okay, never mind. That's the idea. And then the middle part... let's go down a bit. The middle part, right? We can use the hinge attached to the bottom side here. Okay, and this piece in the middle, this way it can be folded open to this side instead. Not sure if it's a good idea. We'll see it in when we develop the idea in SolidWorks. Okay, so now the idea of the top part is pretty much done. The idea of the rest of the level would be like this. Either it would be split in half in the middle, right? And then you have the handle. And then this will open up this way. Oh my god, my arrow. What an arrow! Holy cow. You too. You too. Go. 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 Okay. That arrow was pretty bad. This open this way. Pretty much the same though. The same bad. This open up this way. Okay. The other idea I had for the middle level would be to have the slide door in the middle. I mean, the whole thing can be split into 4. There. Right, you have the middle, but you can split this into 4. And this part can be slide into the left and right piece. Right, so we use this like handle this way. Wait. Oh my god. This way. Okay, this one can also be slide in to here. And with this, we might have like a sort of handle that shaped like this. Oh, can I draw? Okay. Thickness a bit. There. Put the handle here so that you can hold it like in your hand when you open in and out. Right, and this one will be supported by the hinge on the side. This one will also have like some safety to it, so that you can only turn this one if you slide it through all the way. So we have like the ridge on this side, on the top and the bottom, and that should cover the prelim. Usually I'm that lazy of a boy, I'm sketching like 2 pages and I'm going straight into the 3D. Okay, now we'll look at the 3D. Okay, let me go back to the paint for a bit. Let's have a little break since we are about an hour in. Let's have a short 2-minute break. Now, when we come back, I'm gonna talk about the SolidWorks workflow. Right, on the second hour, we already come into the 3D modeling part, which is nice. That's just kind of what I expected. Now I'm hungry. We might only be able to finish the base for the subject, which is the board itself, and maybe make a drawing out of it, and then I'll have to split the episode to the next one. But give me a sec, I'll be right back. Okay. I should off first. With this? No, not this. This. Okay. I can actually write it down so that whoever comes here is not confused. B right back. I know, it all misspelled. How are we doing? I went to pick this up. I haven't measured anything back there, so I'm gonna be measuring this cupboard while I'm making it. Okay, so now I think we're good to go to this. The screen. Which screen? This screen? Oh, my mouse. Check for something. If it's okay, it does. Now, so will be actually SolidWorks. If I'm gonna introduce the software, is the software for engineers mostly, but we use it as a designer. So we're gonna take the designer's approach. Like some engineers do use this method when designing, but most engineers, when they use SolidWorks, all right, the SolidWorks will have what we call part, which is basically a pieces of like the material put in pieces separately. You may have this like cylinder, right? So parts. And then in SolidWorks we have assembly. Oh, I forgot to put up my webcam. So the assembly is something, it's the other file totally. Something that you can put together these parts, okay, together, so it make somewhat the final product. It might be put it here like cylinder, or you can put cylinder here, you know, and have other parts like put there, for example, right? So these are two distinguish way to model. I mean, not model, but they are two different working pieces in SolidWorks. Which, this one that I just explained, is the engineer's approach to when using SolidWorks. So this one is engineer, but with the designer's approach we will do it differently a little bit. Okay, instead of having the part in pieces, let's say we want to design a table, right? We'll design in the part that contain every pieces together. Okay, let's say that the table looks like the one above that we just draw just now. Okay, yeah, so this is the table, which we will do it in the part file. Then after that we'll port it out to the assembly. You see now that the approach would be different, like we work in backwards, because this way we can see the product as a whole when we design it, and then when we try to produce it, it will be exported into the assembly. Not assemble. Yeah, assemble is the verb, but this is assembly, the noun. The assembly will look the same as when we design in the part. Okay, but this is in the assembly file. Even though it looks the same, it can be splitted into like separate pieces. Okay. Now, what assembly can do is it helps us to design the interaction in between the pieces, like when they put together, when we are about to produce the stuff, right? Because as a designer, you have to work on both parts in terms of the finalized product and in between, meaning like the small details in here. This might not be looking like this. It might be looking like having some rips on it, somewhat whatever, right? Or this can have like a planar plane around it so that it can attach to the above pieces, which the above piece might have to have like some rip or boss in it in order for it to take this piece in. See what I mean? And this might have to have like a hole to be able to put the pins from here attached down into here. So basically we are working as a product designer or industrial designer. We're working as both designer and engineer at the same time. There are also, of course, pros and cons between these two approach. Okay. So this approach, pros would be straightforward. Because this is the way that SolidWorks supposed to be worked on. Is that you create each part, number 1, number 2, and then you will assemble it in the other file so that you have wait, this is number 2, right? Number 1, depth, you have 1 times 2 pieces and 2 times 2 pieces, for example. This way is more straightforward when you design the thing, and how it's how the program was designed to work in the first place. So that means it's less back and forth. Between files. So you work one way, and like you start up with the parts or the pieces, and then you go forward and to assemble them, right? It's a one-way trip. But the cons are you can't see the big picture. While designing. Okay, so in order for you to see the big picture, you have to go up from this part out to this part before you can even see the big picture. See what I mean? Like you have to have every pieces. Then once you assemble it, then you can see the whole thing. Okay, so that becomes harder when you're trying to design the interaction between the pieces, right? Because that way you have to go back and forth between the file in this way to change the cylinder, then to change the square, then to change the cylinder again. Like you have to switch back and forth with this way, right? But it's straightforward in terms of like you do it one way part and put it together. Okay, now this approach, the approach would be yeah, just the opposite of the other approach, which is to see the big picture. Of what you are designing, like the overall. That makes it easier to make revision / iterations to the sketch design. Iterations, oh my god. Can I spell, please? So, like, for example, you can just stay in this area for the most part before you are ready to make them. Then you can go forward, right? So it will have less back and forth in the design process because you stay in the same file before you even move to the assembly file. But the cons would be it's a complex workflow to do. Even some engineers taught in the SolidWorks courses, they can be confused working in this way. Compflow, what the complex, not compflow, what the hell, complex workflow. So in other words, it's hard to follow, but once you get it done, it's not that hard. I can show you what I mean. Okay, so now we start doing SolidWorks. I'm gonna move away my Wacom because I don't need them anymore. I'm gonna be using the mouse for this. Using left-handed mouse, by the way. Okay, now this is SolidWorks, guys and gals. We start by starting a new part. Okay. And as a good practice that I just showed you before, we should go back and save this one too. We have layers, so we can save it as the same thing over the same file. Come on back, SolidWorks. SolidWorks doesn't want to work. What the? There we go. Okay, so this is how it works. When you come in here, you are given with the standard 3 planes. As you can see here, it would not be shown, but it is here. Basic control, you use the middle mouse, the one with this thing to, okay, let me see. Right, you use the middle mouse to move around, to rotate around the model. Okay. You then have the option to use control and middle mouse to pan around. It won't rotate if you press control. Okay. This is the middle to rotate, and control with the middle is to pan. You can use scroll to zoom, or you can use the alt. Not alt. Alt is to rotate to the sides. Wait. Oh my god. This thing still cannot handle SolidWorks with Stream. You have control to pan, and you have shift with the middle mouse to zoom in and out. Okay. Right now, so first we start by we have to plan in advance as well, in order to have a smooth design. So first, the first file, we'll save it first. Yeah, as a good practice, we already created a folder, the working folder. We should always save the file in that particular working folder so that we don't forget. This first part will be the big board. Subject. Okay. Yeah, we can actually do the right plane extrusion. Is kind of easier this way, I think. The origin, we set origin to the back always. Yeah, the cupboard will be turning to the left side. And now we can fillet this. Might not be a good choice to do, but we'll see. Now, what did I not dimension? Overall height. So now it is when we should measure things, at least. I mean roughly, because I'm so lazy. It is 165 centimeter, that is 16510. I need a new computer. I need it quick. Seriously. Now, is that high? But how deep it is? $30 centimeters, that is the 300. How do I? Okay. The radius. Yeah, radius is 10, which is 100 mil. 100 mil. It will break. It will break. I know it. Oh no, it's not. Now we can define the depth of it. Yeah, this part is when I say, you tell me that this does not look like I'm playing games right now. Really. It is 300. Okay. If I have a pretty more powerful machine, it would be a lot better, man. Maybe next week. The whole thing is 800 mil wide, but we are gonna extrude it from the middle. So we're gonna choose mid plane with 800 mil units. Okay. Oh, sorry. Right. So we could use multiple approach for this, but I would just would like to shell them. That's easier this way, I think. I would just shell every open side. To the thickness of its to the thickness of the wood, which is 15. It is 15? Yeah, it is 15. So I shell for 15 mil. Shell inwards. If I show preview, it would show the outline of the inner that it cuts out, you know. Well, this is my first time using SolidWorks in like 4 years, man. So now we got the base. We actually oh, okay. Okay, it extends down to here. That means, so this is the power of the parametric. If I mess up somewhere, I can easily fix it. You know, I could just edit the feature. Right, I only select this one, but now I want the open side to be in the bottom as well. So I just like rotate to the downside, to the bottom side, and just pick it. Once I press OK, it will be updated. Okay. Now we can split the two big plates to have its own body. My God. My computer cannot handle this. We'll use split. Oh, I miss using this shortcut. Split the body, cut the part, and then we will check this one out. Override, no. Do not consume. That's all we need. Now these will be separated into 3 pieces. You will see that there's like this piece and these 2 pieces on the side. Now we can assemble the footing, I guess. The footing can be extruded out from this part, which will take the relation of this edge, I mean this spot, we call that vertice. From that vertice to this edge, to this line, I mean. Then we specify the height of it, which is I'm even too lazy to go down there. It's a 10 centimeter, that is 100 height. We'll just do it roughly. Okay. If it's gone black instead of blue, we're good to go. You tell me if it's not feels like playing games. There, since it is extending up to this, we don't want to merge, so we do up to surface. No, it's not. It's not up to here. Okay, let me just zoom in here. If we do up to surface, it will just come to here, right? But we don't need that. We don't want that. We want it offset. Offset by about think it should be 10 mil. There we go. Yeah, it should be about there. Now, the next part is kind of tricky. Actually, we can do it from the side. Yeah, we can do it from the right plane, just like the first. If we want to look through it. This one. Yep, now you see through the thing. Okay, this is like it's a full 30 mil brick, man. It's alright. It extends out from here. Yeah, up to the edge of the front. Oh my god, I misclick. Let's move this here. Attach it. This would be 30. And now we gotta define how high it is from the top. Yeah, we can actually define it by how high from the ground, actually, if it's better. Not really. Yeah, it would be easier for us to measure, actually. Around 475. I'm so lazy. 475. It's a rough measurement at this point. Okay. Now for the magic of wait. Oh my god, it loads for so long. I'm so not used to use the laptop to doing this type of thing. We don't merge the result. We do mid plane. No, we actually do out to surface. This part. That's up to there, and the other direction we would want to go up to surface as well. To this surface. No merge. Thank you. Now we got the how many pieces? The 5th pieces is done, and with the power of the magic of the 3D model, we don't have to do it again. We could now just features and face. No, we want body. Yeah, this is called the pattern. We could pattern the body, which is this body, up to we can have more there. We can do it 2 times actually. We can do one first. Okay. Then we can repeat the same command with the same direction and select the body. The existing body is fine. Yeah, whatever the height it is, we can adjust it later, which we will now. It's about 37 centimeters apart from each other. That means 37. Oh. Same thing goes to... We can actually... Yeah, we can assume it and we can use the formula for it. Equals... what? Equals this. Yeah, D3 at pattern 1. Nice. So now it will always be the same height as this one. Can you rebuild, please? Right, if we say this one height is 400, it will reflect the same amount. Okay, you see that the spacing will always be the same, but this one needs to be 370. We could extrude it from this side, should matter. Extrude it with using one line, easy enough. Roughly 20. Roughly, I mean, and then we need a distance from this edge as well. That should be like what? Oh my god. Yeah, roughly again 20. I will do the precise measure like later. Later, Gator. It doesn't look like. It doesn't look like it. It looks like this one is a 300, I think. More like it. Come on, update. Okay, cool. Now. Yeah, I think it's a 15 mil thickness. We do... Again, we could offset from surface. Right. Oh, I'm too lazy to even use the measuring tape now. I use my hand to measure now. It's 100 distance from the edge. Maybe a little less than that, you know? Say 50. Yeah, that's about right. We do 50 with the thickness, thin feature for 15 mil. We don't merge the result. We never merge the result because we want them separately. Okay. Now we fillet this part. I mean this edge. We only take about half an hour to model this thing. It's going to be 100 mil radius. Now we can linear pattern. This side, the body is this one. No. My god, deselected. Dummy. Come on, click on here. Gimme. Please don't freeze. Click on the body and choose this one. up to reference to this reference and back about, what was I saying, 500? This way? Okay. Selected reference. I've never used this feature before. The heck? Never mind then. I will learn how to use it later. How? Okay, spacing and instance then. Only 2. Thanks. Not 500. Let's say. Whatever. We can drag it later. So the power of the SolidWorks is we can do instant 3D here. It should be around there. Yeah, there are a couple of extra things which I'm not gonna even get into right now. Maybe. Yeah, it's a standard part anyways. So right now we have the cupboard done. I'm gonna save the thing. I will show you the process of assembling this thing. In the case that we want to rebuild this cupboard, okay, what we want to do is proceed to make assembly from this part. Now, the tricky part of this workflow would be that would be that we have to import it one by one. We cannot do automatic, can we? I can't remember. Let me check. Let me check if I can automatic this thing. Assembly from part, that's it. How about this? Oh, I think the way to do it is, yeah, even I forgot about how to do it. I make a new blank assembly. Okay. Is that the way to do it though? I can't even remember. And then we do what? We do import. Start a command. Make virtual. Huh, for real I couldn't remember this part. Because if I put it here, it won't be. It won't be in multiple pieces then. We do it on the front plane. We will insert component. Okay, yep. It's a component. It's the same thing then. Wait a sec. That actually insert from part supplies doesn't. Is that the new thing? No, actually not. Not this command. Oh my god, crap. I couldn't even import it to this, right? It's not open. Yeah, there should be an option there when you create the part from assembly. Is to create it from the body. How? But how? Search a new part. No. Okay. Intermission. Come on. Assembly from part. Do I have to Google this shit? I kind of forgot, for real, man. So if I press this, it will just insert it into here. But how am I gonna? Oh, I think I remember I have to create the configurations for it. Yeah, that's one downside of this method. It's so freaking complex, man. New config. Let me just Google it, dude. Seriously. There's a way that's better than this. SolidWorks. Create assembly from multi-body part. Yep, that's the way. Cut list? No. Yeah, Go Engineer. I remember the website. The way we do it. Oh my god, is it insert? Yeah, yeah, okay. Yeah. Save bodies. Yes, now I'm starting to recall some of these. Except the cookies is okay. Alright, let's just read it all. Read it all out. Shall we? Does it zoom in? It does not. Okay, go back. So, in this article, we'll show you the steps to convert SolidWorks multi-body part file, which is what we have at the cupboard, into a SolidWorks assembly file. The step listed below can be useful when creating molds, as you can easily model everything at the part level, and then move into assembly drawing to simply create your annotations. Okay, for example, the figure 1 is a multi-body part. Up to 8 individual bodies. How many we have? We have up to 9 bodies, which is not a problem at all. To convert the multi-body part, go insert features and then save body. Optionally right click on the solid bodies folder and select save bodies. Oh, we can do that. Next, and select the desired part and assembly templates. Okay. After selecting, you have the option to change the name of each part. Yeah, I remember this part now. Okay, let's go. We will just close this assembly first. We don't need it anymore. Yeah, this one is busted. We're almost done, boys. Within under 3 hours, we have one cupboard with drawings of it. We can select here and save bodies. Oh my god, that's how. Then, we can actually export only the body that are essentials, you know, like the rest. Wait, the rest can be left in there. We want the left side. Is this the left side? Okay, this two. Also this. Okay, we'll call this one. Oh my god, the name. The naming. This one can be. What do we call this? Wood plate 1. This one is the side board. We can leave this one out since they are the same part. This one can be splitter. That all we need? Yeah, that's all the part we need. Replicate visuals property. No, that's the same body. Origin location, we don't need that. Yeah, we need to create assembly. Split assembly. Okay, now we can call this big board assembly. Derive resulting parts from similar body or cut list. Yeah, we should be able to. Oh my god. There's not cut list. Yeah, we haven't prepared a cut list. Never mind, I messed up. We're gonna do it manually then. Again. This and this. Yeah, the way you create it before is that you have to make the cut list so that you define which part is which. And once you do this process, then you can have it automatically put together. But this one we semi-automatic it, which is which one is which one? Boss extrude. We call it footing. Split 1. We call this side board. And this one we call it splitter, right? Come on, computer. Respond, computer. Okay, that's the splitter. And what is it called? Plate board. We need the backboard. Where is it? This one is the split. Yeah. Huh? Backboard. Now we do create assembly, and once we tick OK on this, it will save all the separate part, right? And then click OK. Template used to make the right part with different units. Oh my god, really? Oh, it was changed. Yes. Change the unit to the base part, just please. Do I have to click like 6 times? Don't show again, please. Yes. Always. Don't tell me it comes in like inch. Now this part is automatic. Rebuild, yes. Of course. I will. Alright. This is the part file. We save this. Have we opened up that thing? Okay, we have. So since this is the assembly already, we'll have to do some extra to duplicate these as well. Okay, this linear pattern. Down to this way. Tree with 37. Blah, blah, blah. The rest are just fine. Okay, now we could also use the right plane to mirror the component, which is where mirror components there. This and this. Yep, that should be done. Now that we are already in here, we can make the exploded view. Okay. So let's show how it will be assembled together. Wait, what? This is a micro step? No, I don't want that. No, get out of here. Come back into exploded view. Exploded step 1 is this. Why are there? I'm done with that step. How do I? Oh, it. Okay. Now I get it now. The system changes a bit. So now, how do I remove this thing? I couldn't remove it? Seriously? I can click to remove it. Step 1, click done. Yes, finally. Now I can click this and yep. Step 2 is done. This one can go back here. Done. And this with this should go up. Now we can finish. So this is the exploded view. that we can use in the drawings. How do we unexplode it? How do we toggle it again? Exploded view. No. Whatever, man. I'll find a way to do that again. I knew how to do it. I just forgot. Where's the exploded view? Now I understand the frustration of the student that they couldn't find the commands for exploded. Exploded line sketch. Is it in here? Yeah. How do? There. Okay. Good. How do I deactivate it? Okay, now. Right now we're done with the assembly. The next part is to have the drawing ready to be made. We just save this. Save this. And then we can make drawings from it. Then I could go eat. How big do I have of a paper? I guess I could use A3 maybe. Yeah, we do A3. I have A3. It's kind of too big, but never mind. It doesn't matter. I have paper. I have the printer. I have the paper. Why not? Right? Why not? Why the heck not? The first page that we should be doing is the overall dimension of the drawing. Can we do multiple? Show exploded view. We just do this. Explode. I put in exploded view first. Not a very good practice, but it's alright. Now we can add the isometric. Wait, it should be here instead. This should be there instead. Now, we could add the model view that used to be project. Is it this one? Every icon is so small, man. Front first, of course. Put it here. Wait. Yep. Front. Put it here. We project it next, which is prompted. Of course, it's prompted. The right and top, of course. Yeah, we leave some space for the title box here. In the first page, we don't need anything much other than the overall dimension of it, which I'll just like lazily put it on here. Come on, move. Okay, there. This one goes this edge. No. We can do top and bottom. There. Now we have the three basic views. We can add a new page. This one should be, oh my god. The bill of materials, man. How do we do bills? How do we do bills? Oh my god. Bomb. Table. Bill of materials is automatic. Please be automatic. Select a drawing view, specify the model. Okay. We do drawing model first. This one. Then put it here. The bomb table will be on the right side, maybe. Actually, this part is like so far I can't remember if I'm gonna do it properly or not. The bomb would be here. Bill. Top levels only. I don't know. I will just trust the machine then. Oh my god, it works. Okay. Now, how are we gonna go around specify these parts? There. No. There's a call out. Yeah, okay, it's called the... Oh, there's auto balloon. Of course. Of course, there's auto balloon. Auto balloon me, baby. Always love it. Auto balloon. Hell yeah. Oh, hell yeah. Right now, I'll just change the scale. The sheet scale should be 1 to 20. That big. 1 to 10. Yeah, 1 to 10 is fine. My god, my balloon breaks. Why? When the balloon fails, we could just select all of these or delete them, right? I think. Yep. Easier to remake them than edit them. Of course. Okay. Wait, not a balloon, the auto one. Auto balloon. It's 1 AM. I'm pretty much not sleepy at all. On the left side. There we go. Move this up. How do I? Whatever. It reordered itself. Okay, cool. Come on now. Okay. We press check mark. We'll move this. Can we scale this? It's not just games now. It's on everything that this machine couldn't handle while streaming. I think this is because this lack of the GPU. I need to get the GPU quick. I think I've said it like 3 days in a row already. Okay, we're done. We're done here. We'll skip the part where I do the tedious task, which I would lay out each part into each sheet's drawing, and next time I'll show it that with the printed version of the drawing. How about that? So that's about it for today, I think. Yeah, for episode 1 in the design workflow, I just showed how we approach the SolidWorks software as a designer. So we don't have to create each pieces separately. We just create the whole thing. We port it onto the assembly, and that's how we do it. Okay, I'll see you in the part 2 where we will be actually designing the acrylic frame that I mentioned about, that I was briefing about. And with that, I'll leave the stream right here. Thank you all for watching. I will see you next time. Goodbye. How do I shut this down?